So today I am going to give the solution for the question problem, maximum frequency of an element after performing operations. So basically what the question is telling is, let me explain you. You are given an array nums and you have two integers k and num operations. So you can perform num operation. In each operation you have to select an index I that has not been selected before, and to that index you can add anything in the range minus k to k. After adding that, the new array that will be formed, so you have to return the maximum frequency of any particular element. So let me explain it in a better way. Suppose this is an array. Suppose we have an array of elements 2, 3 and 4. Then take it 11. Suppose we have k is equal to 5. So question is telling k is equal to, let's take it as 2. So now the question states that we have to tell what we can do is, and suppose num operations is 1. Suppose we can perform operations one time. So what is the question is saying, that you have to choose any index which has not been chosen. It means that you have to choose an index at one time only, and in that what you can do, you can add minus 2 to that index, and you have to return the maximum frequency that is possible. Suppose we can add only once. Suppose we add 2. In 2 we can add anything between minus 2 to 2. Suppose we add 2, it becomes 4. Now what happens, that 4 and 4 is repeated twice, so the max frequency is 2, so the answer will be 2. In any case it will be 2, it cannot be changed. Let us see what is possible. 2 plus 1, 3, 3 and 3, again it will be having answer will be 2, because two things have same. One more thing is possible, if the number of operations would have been more, what we could have done, 2 plus 1, 3, 4 minus 1, 3. In that case our answer would have been 3 if the number of operations would have been 2. So like that we have to perform. So I think you have understood the question. Now we are going to the solution part. Let us take example test case. There is nums 1, 4, 5 and k is equal to 1. Now operations 2. So what happens is that in 2 times you can perform an operation. So nums 1 at 4 you are adding 0. Okay, so basically you have performed operations, so you can also add 0. 0 is an option, so it is keeping the number same. It is like keeping the number of same. So num operations is basically the max operation you can perform. And nums 2 we can add minus 1, so 4 and 4, 2 elements becomes the same, so it has the max frequency of 2, right? Now let us jump to the solution part. It is our approach is simple. We are taking an unordered map, and in unordered map for all the elements we are storing the frequency of all the elements that are present in the array, like how many times it is being used. And after that, after finding the frequency, what we are doing is that since the range of nums is in 10 to the power 5 till 10 to the power 5, so we can easily iterate. Element is 10 to the power 5, so we can easily iterate from for each element 4. So what we are doing is that we are iterating from the smallest element to the largest element. Like we are assuming that suppose this particular element is possible, is having a maximum frequency after the applying the operations. So what are the possible things that can be, what are the possible elements that can be converted to that that particular integer after in the limited constraints, like in the num operations, number of operations at max using at max num operation times what is the minimum, what is the maximum number of elements we can convert to a particular number. So we are finding that. So let us see the approach. We have taken an unordered map, we have sorted the array. Now what we are doing is we are iterating in whole array, and then we are trying to find out if the number is not equal to last number index which we have taken, so it is a different number. So now we have got the index of the last index, and the current index is the index of the new number. So since it is sorted array, so all the elements in between would have been the same number. So now we are counting the number of how many frequency of that number, and we are storing it. Along with that, since these numbers are available without the any operation. So we are assuming that yeah, this is the maximum number of frequency that is already present. So we are storing that in the answer, and we are updating last term index to I, and we are performing it at the last, after the last, so that the last segment also gets tracked. Now we are coming to this part. What we are doing here is, since our array is sorted, so what is the best case? The possible options that the integer after operations will be converted to a particular to a different integer after applying the operations. So the best way, optimal way, is to convert to a particular integer which is in the range of lowest number to the largest number, so that it can be easily converted. So what we are doing, we have taken the lowest number and we are iterating it to the largest number. We have taken a lower bound of I minus k. It means that suppose I is the number to which we want to convert all the maximum possible integers, elements of the array. So what we are doing, in the nums we are finding the index of the number which is just greater than or equal to I minus k. So all these numbers can be converted into I by adding k. And what we are doing, we are again doing the upper bound of I plus k, means we are doing upper bound of I plus k and we are decreasing it. So we want to convert it to I, so we are finding the max, so we are finding a number which is greater than I plus k, and then we are decreasing one iterator, so that we can reach to the last element which is I plus k, which is equivalent to I plus k. So that can be easily, and we are finding its index, so that can be easily converted to the I. We are doing this upper bound, the reason is that there can be multiple elements. So I plus k, suppose I plus k is 5, so there can be multiple 5. So we are taking upper bound so that we can reach the last 5, so that 5 can be converted back to the our I. So that is the reason we are using upper bound here, and we can, so that we can reach the most rightmost element, and here we are using a lower bound so that we can use the most leftmost element. After that, what we are doing is that we are checking if the I is already present. Suppose if I is already present, and we do not have to waste our operations on that particular number. So if the I is already present, then what we are doing, we have found a range r minus l plus 1, but we have constant, like we can use num operations only. So what we are doing, answer is equal to max of answer, minimum of number of operations that are available plus mi. Already I frequency that is available there, we are using that, so that mi plus num operations, comma r minus l plus 1, and that is the case. But if suppose mi is not present, like means the frequency is not, that element was not already present in the array, even without applying the operations at the beginning of the question. So in that case, we do not have any mi, so we can simply take what is the minimum among the length of the element that can be converted and number of operations we can apply, and thus we can return the answer. So thank you.